So, have you ever really stopped to wonder what happens when you click on a link? I mean, how does all that data fly from a server somewhere on the other side of the planet to your screen in like a fraction of a second? Well, today we're going to demystify that magic. We're breaking down the OSI networking model, which is basically the rule book for how the internet actually works.
And we're doing this a little differently. We're going to put our expert to the test, peeling back these layers one by one to see the whole process. This isn't just about some dry theory. It's about understanding the practical steps that make our digital world go round. So let's get started. All right, we're going to start our examination right at the top with layer 7, the application layer. This is the one you interact with all the time, probably without even realizing it. It's where your browser, your email client, all that software plugs right into the network. So for our first question, in simple terms, what exactly is the application layer? Okay, so you can think of the application layer as the interface. It's the bridge between the app you're using, say your web browser, and the rest of the network. Your browser doesn't need to know the nitty-gritty of how data gets sent. It just needs a standard way to say, hey network, go get me this website. And that's exactly what this layer provides. And it does this using a set of rules, or what we call protocols. You see their names all the time: HTTP for websites, SMTP for sending out your emails. But probably the most important one is DNS, the domain name system. It's literally the internet's phone book. It's the thing that translates a simple website name like google.com into a numerical IP address that computers can actually understand and find. Okay, that's a clear start. So the application layer makes a request. But what happens next? How do we make sure the data is in the right format, and how does the connection even stay open? Well, that's where the next two layers come in: presentation and session. So let's move down to layer 6. What are the main jobs of the presentation layer? Right, the presentation layer is basically the network's universal translator. It has three main jobs. First is translation. It makes sure the data is formatted in a way that the application on the other end can actually read it. Second, it handles encryption. This is huge. It's where your data gets scrambled from plain text into secure ciphertext for safety. And third, it does compression. Shrinking files down so they can travel across the network way faster. Excellent. Now that the data is all prepped and ready, something has to actually manage the conversation. So what about the layer below that, layer 5? What is the session layer's role? The session layer. Its job is simple but absolutely critical. It's the dialogue manager. It's responsible for opening the communication channel, keeping that connection stable for as long as it's needed, and then, when everything's done, closing it down cleanly. It basically makes sure the line doesn't drop mid-conversation. Okay, now we're getting into the real guts of it. We're diving down to layer 4, the transport layer. This is where a lot of the heavy lifting for data delivery really happens. This is a big one. So what is the fundamental purpose of the transport layer? What makes it so essential for reliable communication? The best way to think about it is like a super reliable postal service. Its entire reason for being is to make sure the data gets from point A to point B. And not just that it gets there, but that it gets there completely, without any errors, and in the right order. So to do that, it juggles a few key tasks. It takes big chunks of data from the upper layers and chops them up into smaller, more manageable pieces called segments. It then keeps track of each one to ensure they all arrive. And if they show up all jumbled, which they often do, it puts them back in the correct order. And all the while, it's constantly checking for errors to make sure nothing got corrupted on the journey. Fantastic explanation. Now, this brings us to one of the most classic debates in networking, the two main ways the transport layer can choose to do its job. I'm talking, of course, about TCP and UDP. All right, so the transport layer has these two very famous protocols, TCP and UDP. They're fundamentally different in how they operate. Can you break down the main differences for us? Absolutely. Look, it all boils down to one thing: a trade-off between reliability and speed. TCP is the reliable one. It's connection-oriented, which means it establishes a formal connection, what we call a three-way handshake, before it sends anything. It numbers every piece of data and waits for the other side to say, yep, got it, for each one. UDP, on the other hand, is the speed demon. It's connectionless. It just blasts the data out there and hopes for the best. No handshake, no acknowledgements, just pure speed. And you can actually see the price of TCP's reliability right in the data itself. A TCP packet has a 20-byte header, while UDP has this tiny, lean 4-byte header. That extra overhead in TCP is where all the magic happens. It's full of sequence numbers, acknowledgements, and other info to guarantee delivery. That's why you use TCP for things where every single bit matters, like loading a web page. And you use UDP's raw speed for things like live video streaming or online gaming, where losing one tiny piece of data is way better than lagging.
That really clears up the TCP versus UDP debate. Now, to wrap things up, let's look at a few other smart features the transport layer uses to keep everything running smoothly. So apart from just chopping up and reassembling data, what other key control mechanisms does the transport layer have up its sleeve?
Well, there are 3 other really important control features. You've got error control, which uses something called a checksum to make sure the data didn't get scrambled. And then you have 2 that sound similar but do very different things: congestion control and flow control.
Right, and it's really important to get the difference here. Congestion control is all about the health of the entire network. If it senses a traffic jam somewhere out on the internet, it tells the sender to slow down. Flow control, on the other hand, is a personal conversation just between the sender and the receiver. It's the receiver saying, "Whoa, slow down, buddy. You're sending me data faster than I can handle it."
And that really brings everything together. So for our final question, how does it all fit? When you put all these pieces together, what you have is this beautiful, layered system where each part has a specific job. The application layer turns your click into a request, the presentation layer encrypts it, the session layer opens the line, and the transfer layer makes sure it all gets there in one piece. The next time you click a link, just think about that perfect, harmonious cooperation. That's the real magic behind it all.